to the XP Solutions XP Live webinar. My name is Jessica Jeffries and I'm the Products Manager here at XP Solutions. Today's webinar will discuss emergency and evacuation planning tools. We'll cover some key concepts and show you how to use these tools in our software. So this is part of our XP Live educational program, and you'll find all of our previous webinars have been recorded and are available at the website link on the screen now. This webinar will also be recorded and posted online in case you want to share it with any of your colleagues. Our discussion on emergency and evacuation planning is going to cover some key concepts and goals, run through some of the guidelines. Then we'll look at tools and how you can use these tools to produce outputs for evacuation planning. We'll also briefly touch on how this can help community expectations, and then, as I mentioned, there'll be a question and answer session. For those of you that don't know XP Solutions, we're primarily known for our software packages XP Swim, XP Storm and XP2D, and this is software for modeling wastewater, stormwater and flooding. It has a graphical user interface and analytical engines that can help you do a range of tasks. It includes CAD and GIS type interfaces and data management tools, and there's also a wide range of graphical reports, maps and animations. The 1D engine solves the complete San Fernand equations, and the 2D engine solves the shallow water equations and is embedded as XP2D. So why are we talking about evacuation planning? Our stormwater and river systems typically operate in a controlled state and provide amenity to the communities that live around them, as we can see on the left-hand side there. But occasionally the hydraulics change. We get a lot of rainfall and extra water in the system, and then we have to deal with the flooding, and we need to plan for this eventuality. So this photo here on the right shows a typical scenario of flash flooding caused by surcharge into low-lying areas and is affecting roads and access. And it's this sort of event that's causing the management of flooding and its impacts to become a major focus for local and state authorities. So we're seeing emergency evacuation plans and emergency evacuation management actions in response to flooding become more important, particularly when they affect the entire community. So we'll be talking more about inundation maps later, but these are a particularly useful tool for emergency management authorities. They can help to develop warning and evacuation plans, in particular because they can help us understand how much time we have after a flood event begins. It's really important when we're conducting an evacuation operation to know how much time we have to respond. And the timing of the flood, as well as the depths and the velocity of the flood waters, are all critical for producing a successful emergency evacuation plan. So across the various different countries, various different regions within Australia, where we are at the moment, there's numerous guidelines on preparation and planning requirements for emergency evacuation. We don't have time to go into all of the details for all of these different guidelines, but we'll touch on a few of the guidelines and talk broadly about what these guidelines cover and how we can use the tools that we have available to help us to meet the requirements of these guidelines. So some of the key guidelines in Australia come from Emergency Management Australia and cover emergency planning and evacuation planning. There's other guidelines elsewhere in the region, and elsewhere in Australia, such as the Queensland Reconstruction Authority and guidelines from the Indian government shown there. And we've just put a few links in this presentation which you'll be able to download from our website afterwards to some of the guidelines that we're mentioning in this presentation. So what do the guidelines cover? Typically, guidelines on flood management and on emergency and evacuation planning tell us that we have to understand the flood risk. So we have to understand the type of flooding, what the source of flooding is. Often the pre-flood conditions are also important. We don't necessarily know this when we're building a software model, but this is important actually at the time of the flood event to help us determine whether there's anything that might be exacerbating the flood itself. And we need to know the impact and the severity of the flooding. That's partly where modelling comes in, because it can help us to predict where the flood extents will be and how deep the water will be and how fast it will be flowing. We also need to understand elements of community vulnerability. And when we say community vulnerability, we mean the vulnerability of people and property. So it's not just about the loss of access for people. It's also about whether our hospitals, our critical utilities, water, electricity, and our emergency services can actually operate during a time of flood. The loss of access, the loss of communication for these types of services and property can be critical as to whether we can actually get people out safely. So timing is very important, as we've mentioned, and we'll show examples of how we can actually produce outputs which include timing to help us plan for flood events. And of course, seeing what property is at risk of damage. The other thing that emergency planning guidelines cover is assembling information during a flood. So it's very important that we've actually made a plan to have access to this information during a flood, access to things like flood maps, inundation maps, evacuation routes, and that this can be presented in a way that's easy to understand and easy to disseminate. So one example from the Queensland Reconstruction Authority guidance is this table here showing flood hazard criteria. So this gives an indication of at what depth and what velocity of water we exceed certain hazards. So we have a low, significant, high and extreme hazard, and this combines the depth and velocity and tells us whether it's safe for vehicles, cars and so on to actually be in flood water in certain conditions. Other guidelines have other similar tables which may have slightly different levels. Some guidelines simply talk about depth, for example when it's safe to be in a road, and this is the sort of information that's required to develop an evacuation plan for your region. So you need to make sure you know which are your local requirements with information like this contained in them. And to present this information, we primarily use hydraulic models. So we'll look in more detail as to what those hydraulic models can actually produce to help us. Typically, when preparing a hydraulic model, we need the following information. We need survey data, catchment conditions, details about the infrastructure, and we need to know what storm we're actually preparing for. Is it a 1% storm or a PMP storm? How extreme an event do we want to plan our flood evacuation plans for? We may also look at different scenarios. for example, whether if a blockage occurs, how that affects the flooding. In the past, undertaking this modelling analysis was typically limited to 1D models, and flow path determination was more uncertain due to the types of output available from 1D models. For example, a user may have had to predefine the flow paths in a 1D model, and that would require manual interrogation of a digital terrain model. In addition, the extent of the flooding, the velocity, the hazard and other outputs were not always available. Our 1D results were often extrapolated onto a 3D surface, and this does still occur in some cases. There are still 1D flood maps produced. However, we have to recognize that there are limitations in taking this approach, and it's for that reason that 2D models have become the accepted best practice. 2D models where we're solving the full shallow water equations have the ability to fully represent the overland flow. And we can show evacuation routes and time to flood by using the outputs from these 2D models. So if we look at the software, this is an example of the sort of animations that can be saved from software and used in evacuation planning. So this is useful because we see very visually where the flood extents go on our site, which properties are affected, roads that are affected, and so on. But as well as animations like this, it's also useful to get down into the details and really interrogate the results so that we can look in more specific areas as to whether we actually have evacuation routes affected and whether we actually have time to respond to a particular flood event. So we'll look in more detail now about how we produce these sort of outputs. We have the option to produce from our 2D models evacuation route layers that assess the time to inundation for given predefined criteria. So this is very flexible if we're working with different sets of guidelines in different regions. We can set up these evacuation routes to assess the different levels based on your specific requirements. And we'll look at how exactly we do this in the software. So we have a layer that allows us to put in the information about where we want to see the road cut off, and we'll show that in the software now. And then we can produce a report. So if I go to our file at the moment, just to set the scene a little bit. So we have a development here where a river is flowing towards this developed area. This river's culverted underneath the development. It's a stream really, and then pops out the other side. And we've just got the topography showing the contours on the surface here. Now without a 2D model, what we could do is interrogate the contours, take the levels from our 1D stream sections and pipes, and we could look at where the water goes on the 1D surface using some of the results from the model and also some of our engineering judgment. With a 2D model we can see the actual flood extents of the whole area. And I'm going to show you how to actually set up our evacuation routes and add the additional inundation maps. So if we right click on the 2D model layer, then we can click on Add New Layer. If we scroll down here, we have evacuation routes at the bottom. If I click on that one, it adds a new layer for us. To make this easier to see, I'm going to change the properties and pick a nice bright orange. And I'm going to increase the thickness of this line as well. Now I can just draw where my evacuation routes are. So I can use the polyline tool on the right hand side here. I'm going to look at this road here to start with. And I just draw that line by one click at the end and then a double click to finish the line. It can have additional vertices in if I want to. If I right click on this line and edit the data, my evacuation route screen pops up. So the first thing I want to do is label this. I'm going to call this road 1. And I can actually assess this road and see whether the route is cut off by depth, velocity times depth, which is a measurement of hazard, or just velocity. I've then got the option to add up to 3 different route cutoff values. So I'll set the first one at 0.6, then 0.3, and 0.15. And I've chosen these values because 0.15 typically represents when water will overtop the curb. So I can give each of these a description. 0.3 meters is typically acceptable or unacceptable for driving. So at 0.3 meters we would often define the road to be impassable. And then at 0.6 for adults, you'd say that it's no longer possible for them to be walking through water above 0.6. Now at the moment this is just talking about depth, so we might say that at 0.6 meters the water would need to be still for an adult to still safely walk through that water. At a shallower depth, the water would probably become unpassable for vulnerable people or for adults if it was flowing quickly. But we'll just look at depth to start with. And I'm going to use 3 colours here. I'm going to use yellow to identify the lowest value, orange to identify the road cutoff, and I'll leave red for egress. So what we'll see is when we run the analysis here, along this road we'll get an identification of where this road is first cut. So where this road becomes impassable and at what time that actually occurs. On the right hand side here we have the option to modify the elevations. In most cases we can simply accept the DTM values. So these values have been read just from our digital terrain model. If we wanted to adjust them, we could adjust them by typing the values in here, and a 3D break line would be created. This is quite useful if we don't have the road set up in our DTM as a break line. It just allows us to put that into the terrain model as a break line, and we could also use a 2D break line as well. So I'll click OK to that one. Now, when we run the analysis, as I mentioned, we'll get shown one location along this evacuation route. So if we have multiple roads that we want to analyze, we simply draw multiple polylines. So we could also assess where this road is cut and where this one is cut, and we would just set up the data for each of these roads. So this could be road 2, and we would set up the data. So you can keep adding as many roads as you need to. There's some other tools we can also use for our emergency plans, evacuation plans, and that's a time to inundation map. So far we've looked at just identifying specific routes, normally roads, but we can also produce a map of the whole area. And again, there's user definable map criteria. So we'll show you in the software where you can access this in the 2D job control, and we can set up these options. And this allows us to produce cells that are coloured with user definable depths up to the critical depth, and also for specific depths. And we get additional layers appear in our results so that we can look at these maps individually. So if we go back into the 2D model and right click on the 2D job control, these options appear under model output. So they've actually already been added, but we could have just inserted them. We need to make sure enable time to inundation map is ticked on, and again we can set these depths to whatever we need them to be. We've used the same labels, curb, road and egress, and on the map results types we've ticked on the time to / duration of inundation maps. So this is going to produce additional layers. The other map types that we might want to use are obviously things like water depth, water elevation, velocity and hazards, and there's a whole range of hazards inputted into those map results types which you can run, and we'll also be adding user definable hazard categories in a future release, so look out for those. So if we go to our results, we've actually analysed the model in this scenario, and for our evacuation routes what we can see is, sorry about that, we can see we get a label here. It's a little bit tricky reading it across the photo, so I'll turn that off, and this actually shows us the time that each of these depths has been exceeded. So it tells us first the depth, first the time, sorry, then the depth and the label. Because that's a little bit difficult to see, we've actually got a table as well. So you can right click on the evacuation route cutoff times and click on the summary. And it tells us the name, the cutoff value, the first time it's cut and the last time it's cut, and the actual duration. So we can see that for road 1 it's actually exceeding 0.15 meters for just over 3.5 hours, exceeding 0.3 meters for just over 2.5 hours, and exceeding 0.6 meters for almost 1.5 hours. So this is really useful because we now know that vehicles won't be able to use this road for at least 2.5 hours, and maybe longer if we allow time for cleanup as well. If we zoom out, we can look at the inundation maps for the whole area. So under the times setting here within 2D results, we can look at each of the inundation maps in turn. So in this scenario, we've actually got a blockage scenario where there's a blockage occurring, and so most of the flooding is occurring at the downstream end. And we can see that the further we get from the source of the flooding, which is the river, the stream, the longer it takes for that area to be inundated up to this depth. So we've got the scale here. So out on this outer edge, it's 4.5 hours until it actually reaches 0.1 meter level, And if we look at the duration of inundation, we can see that the darker blue, it's only exceeding that for between 0 and half an hour at 0.1 meters. Then if we look at the 0.3 meter map, the flood extent is not quite as far, of course, and we can look at the durations and again see that, of course, closest to the river it's flooding for the longest amount of time. And these could be set to whichever user-definable depths you want to interrogate. As well as those depths, we can also look at the time to the peak elevation. So we can see here that the time to our peak elevation is actually only 1.5 hours in some area with the blockage. For our base scenario, we've got more flooding at the upstream end occurring. And we can produce a similar map for the time to peak velocity. So these maps are really useful outputs, and they can help us to manage community expectations by sharing this information with the community. And it can also help us to plan for future improvements to reduce the actual hazards occurring from flooding. Thank you for listening to this webinar.